that the fragmentation will be at the optimum size with lex oversize and lex undersize lesser than 5% of the whole mock pipe. So for us to achieve that, if our burden is Sx, then we have issue with our powder factor, because we will be interested in making the powder factor to be such a powder factor that will cause more of the rocks to be effectively fragmented. So if our powder factor tends to increase, then we are still going to tend to the direction of environmental impact and to the direction of economic effect. We know the price of each explosive, the price of blasting materials. The more the powder factor increases, then the more of the carton of explosive you need to move from the magazine to the blast site, the more of blasting materials, the more of connecting cords, the more of detonating cords, the more of shock tools, the more of blasting accessories that you need to perform the blasting. So to avoid that, our estimation is being overestimated or underestimated, we have to work on our burden so as to ensure that we achieve the best blasting under the best control. And also, it's not limited to that. There will be poor body movement. There will be very poor body movement. What is body movement? Body movement is the distribution of energy from the high burden position of the drill hole to the lex burden position of the blast site. What am I trying to explain? That is, there's a particular location in the drill hole that is high burdened. Then there's a particular place at the blasting area, that I mean the free face, that is less burden. So the distribution of energy between the high burdened particular location to the free or less burdened particular environment, the distribution of energy between the two locations is called burden movement. That is, you are moving the burden on the blasting from one location to another, from the burden point to the free face. The free face is the place that is free, that is having less of rock mass. So in the place of blasting, assuming this is the rock mass, we have if it is to be boss cords, or we are approaching the blasting with the boss cords, of which we are tending to create additional free face apart from the vertical free face, or in the place where we are blasting in benches, we have two free face, that is the vertical and the free face facing the black zone, I mean the rock face. So in the place of the body movement, the body movement is the movement of the explosive energy right from the drill hole to the free face, and which is a function of how effective the blast energy will perform fragmentation under tensile slabbing. As I've mentioned earlier, the fragmentation of rock at detonation tends to fragment under three conditions: one under compressive strength, two under shearing, and the third one under tensile slabbing or tension strength. So the tension strengths perform most of the micro cracks, micro fracture. So if the burden is too much, there will be poor burden distribution, there will be poor burden movement from the blast, from the drill hole, the center of the charge hole, to the free face. And if this occurs, then we have less of micro cracks, less of tensile slabbing at detonation. What is the import? What am I saying when I say tensile slabbing? What I'm trying to say is that at detonation, the explosive energy from the explosive, released from the explosive at detonation, which is the shock wave or the shock energy that is expected to travel and come back to the drill hole before the gas energy is being released. As I've said earlier in some of my write-ups, in some of my videos, I mentioned that the detonation pressure and the explosion pressure is different. And I mentioned that one, which is the explosion pressure, and the detonation pressure. The detonation pressure is the first pressure that is released at the CJ plane, which is always twice that of the explosion pressure. The explosion pressure is the pressure associated with the gas energy that is being released after the shock energy has been released. And I also mentioned earlier that there is distance, there is time frame, there is time difference, there is time frame between the time at which the shock energy will be released and the time at which the gas energy or the gas pressure will be released. So within this time frame, the shock energy is expected to travel from the charge point, from the detonation point to the free face, and reflect back due to the low due to the lower condition of the shock, the lower condition in the place of the sonic velocity of air available at the free face. So since the sonic velocity of air is lesser than the sonic velocity of the rock, then the wave, the energy traveling through the rock, tends to reflect back at the free face. So the time taken for this shock energy to travel from the blast point to the free face must be such that the wave travels and reflects back to the point before the gas energy is being released. If this is not achieved, then the gas energy, I mean the gas wave, will tend to feel the fracture, I mean the cracks, just within the range at which the shock energy was able to fragment the rock before the explosion. Then this will create more of oversized materials and more of undersize, because since the cracks is not up to what the gas energy is supposed to field, then the gas energy tends to perform excess work by throwing the rock at high rate and causing excessive fracture at through. So this is very important. This has just little and leads to some of the effect of maximum budding. The effect of maximum budding also, as I've mentioned earlier, will lead to increase in spacing, which will automatically affect our blasting pattern, our drilling pattern, and which will also affect us in the place of we arranging our holes within the blasting or within the blast zone. For example, maybe we are working on the bench of, let's say, maybe 10 meter wide, which we have already designed during our mine design to be a bench that will satisfy all we need, that will contain both the loading equipment, both the haulage equipment, and even the workers. So in the place of blasting, due to our maximum burden, of which we have overestimated, we will tend to overbreak the rocks to the bench face, of which will limit the stability of the bench wall. So we are tend to avoid all this during this blasting. So that's why we need to plan our burden, and we need to make use of the optimum burden. There are a lot of things, there's a lot of rule of thumbs formula that is used for design blasting, in the place of the use of the strength of the rock, in the place of the use of the diameter of the hole being drilled, depending on the bench design. So there's a wide range of formulas that are available for designing burden, so as we can have the maximum burden that we need to perform the maximum work that we have at hand. So as I said earlier, burden is very important. Also, spacing is important, and also the diameter of the hole being drilled is very important, and in the accuracy of the deep direction of the hole. All this is very important, but not limited. Maximum burden also have maximum effect on the drill hole, and also have maximum effect on the environmental impact of the blasting, also have maximum effect on the economic effect of the blasting, and also have maximum effect on the body movement, which results into tensile stabbing at detonation, of which we are interested in having maximum microfracture and maximum breakage at detonation. But coming to control blast, as I've explained earlier, control blast is a type of blast that we are intending to carry out with less damage to the rocks that we are not intending to break. So, for example, the rock that we are expected to abandon and use as the support for the mine face, if such rock is overbreak, if such rock is over-fractured during detonation of our explosive, then we tend to subject the mine workers to high level of prominent to accident occurrences, of which we are not interested in. Mining is interested in safety first. So to avoid that, we need to plan our burden in such a way as to achieve our maximum fragmentation with minimum or no accident occurrences during blasting. Thank you very much. I want to appreciate everyone. As I've said earlier, follow my page, like my page, drop your comments, drop your contribution. Everything is welcome. Thank you very much. Once again, I'm Giants Miner, a student of Federal University of Technology, Akure Mining Department. I love what I do. That's why I'm doing what I love. Thank you very much.